Okay. Hello, everyone. Welcome to Networking and API in iOS workshop. That's the topic that we're going to discuss today. Uh, let's begin with a bit of introduction to give more credibility to my words. I'm Roman. I've been iOS dev for more than 6 years, and I've worked on multiple of apps, including some of the big ones like Meta apps. And I'll give you a bit of hindsight of how today's talk will go. So first, we'll talk about what network request consists of, language features that we'll be using today, and we'll be using Swift programming language, which is the language most of the people nowadays use to write apps for iOS. And then I have a little app with the basic UI, and we're gonna build a network client for it. Okay, so network requests and what they're made of. So basics are they have method, scheme, server, path, and query parameters. I have an example link here. From what you can see here, the HTTPS is the scheme, the server is google.com, the path is /search, and the query parameters is q equal Swift. Query parameters are a bit different from all of the other parameters of the URL. There can be like multiple of them, but the order does not really matter when the order of the scheme server and path usually matters, right? And chances are you already encounter network requests just to get into this meeting. Like the link you've been provided to join this is a network request already. Network request also has a method. It's either get, post, delete, or put. And from the name, it's pretty easy to infer what any of them does. Like get, your intent is to only get something from the remote server. Post, you intend to update something. Delete, obviously delete. And put is to provide something new. For vast majority of cases, get and post will be more than enough for most of the applications and network clients. Now, there are some additional parameters that you usually don't see for the network requests. Those are headers and body, and they are basically the ways to provide some additional parameters and context to your network requests. The difference between them is headers are more of the meta information about the request. So for example, if you have access token or something related to authorization, you would provide that information in the header to network client, to your API. If you need something like provide additional information like I want API to return me data in specific format, you would shove that into header. The body though is more related to specific entity the network request is tinkering with. The important information is that you should not be providing body for the GET requests. Some APIs may reject that, and you will get an unforeseen error. Okay, now the language features that we're going to be using today. First and foremost, enums. Enums. They're a group of related values. If you're familiar with any other programming language, you're probably familiar with most of that, what I will be talking about today. But in Swift, this is how you define an enum. Enum can have something called a raw value, which is here. It can be, usually it's either a string or an integer. The funny thing is that compiler would try to infer the raw value of an enum case based on the case itself. So when it's string, the raw value would basically equal to the string representation of the case name. And if it's integer, it basically will be the index of the case within the whole enum. The important thing to know is that you can have only one unique raw value per enum definition. For example, here, you can also overwrite the raw values. For example, here, I printed the raw value of both of these cases, and as you can see, the only difference is that I did overwrite get to be capitalized, and post is just inferred from the case name. Okay, protocols. Basically, it's a blueprint to define a set of requirements for other types to follow. On the left, I have a protocol that we will be using today a bit later, is network request. And it has a bunch of properties that we need, which is associated type, basically forcing a type that follows the protocol to have a new type defined that we'll be using as the response. As you notice, all of the properties that I have here are basically the same what I've talked about before, except for the base URL, which is of type URL. That's because URL will basically combine the schema and the server for us, and the rest is pretty much the same as I talked before. What you will notice is that these query items and headers, they are dictionary. If you're familiar with any other programming languages, you might refer to them as maps, but in Swift, they are called dictionaries. These question marks, if you're familiar with those are optionals, which basically means object that is optional may not be provided for any reason, like whether an error or just not initialized yet. And on the right, you have an example how to conform to a protocol. Basically, when you follow a protocol requirements, that's called conformance, right? So after you define your type, which in this case is a planets request that we'll be using later today as well. And after calling, we just define the protocol that you want to confirm. And these are the properties that you define. One more thing to note is that this get keyword here is basically meaning that any object that refers to the instance that confirms to the network request protocol can only read these values, but not set them. If you were needed to set the value, you would also write set here after get. Okay, extensions. They allow us to add functionality to existing types. This also includes types defined in a third-party libraries that you usually don't have access to or cannot edit yourself. For example, on the left here, I have the same protocol that I had on a previous slide, which is a network request, but I wrote an extension to it. And what that extension basically does is that it provides some default values for some of the properties, right? So any type that later follows confirms to this protocol does not need to provide method, header, and the query items. Those will be provided by default, but they can override them should they need to. Right. Next slide. Generics. In Swift, they're basically the definition of polymorphism. They will allow us to write reusable code that performs same operation with different data types. Some example of generics are arrays. For example, here you can see array of strings, right? Array of integers. This basically what it does under the hood. It converts the element to int, and array of doubles. You can mix and match those in the array, but then array becomes a type of array any. And dictionary, right? It's basically the same except for it has two values in a generic, key and value, but key also needs to conform to protocol hashable. And we'll be using basically the same today. And asynchronous tasks, the most important part of any networking client. What you basically don't want in your app is for network request to stop your app completely while it's performing, right? So you basically want to perform those requests concurrently with the apps. Maybe you want to display some loading indicator or something like that. On the left, you have an example of how you would define a synchronous method. You would define it with a keyword func, name of the method, parameters if you have any. Async is the keyword required to indicate that method is asynchronous, and throws is the keyword basically indicates that a method can throw an error, and the return type just returns us an array of planets. And call an async method, you always have asynchronous means that it can basically be performed concurrently with any other tasks. So for example, when you wrap it with a task, you can call fetch planets, but you can perform other work in the app, if that makes sense. So for example, you can fetch something from the web while user is still browsing the other page, right? So if you've seen maybe like, if it's app like an Instagram, something there with an infinite scroll, right? When you scroll down, once you reach a certain point, they perform a network request to fetch a next batch of data for you, like posts, videos, reels, whatever you're watching, but the app is still responsive, right? So that's basically it. Does that make sense? Okay, I'm going to assume yes. Now, the API that we going to be using today, called SWAPI, stands for Star Wars API, which stands, I just said which stands for. And we have, it's not big, but it's more than enough for us today. It has like the basic route that we discussed, like the schema, server, path, and we have additional path that we can use. For example, I can say planets, and it will give me a response. I'll copy this to a new tab so it's more visible. Okay, great. Now, the response here, content type is application JSON, and this is basically what it looks like. As far as you're concerned, it's basically a dictionary or a map, whatever you want to call it, and it's also provided in a key value pairs. So count here, for example, is the key, but the value is 60, so it means there are a total of 60 planets. The key here is next, which is the string value of the URL to the next page. Previous page link is not present, so basically that's because we are on the first page. And the results. we have basically here opening an array of results with a square bracket, and each of these curly braces inside an array basically represents the model that we will be using today. So each of these objects is basically the same planet, just with different properties. And what we're going to do now is I have this little app that does not have any planets displayed yet. And what I'll do, I'll just show you how I would fetch those myself. So first things first, I'm going to create a new folder called models. And I'm going to create a new Swift file called planet. And add the planet model, which is the model. I will not grab all of the properties, just a few, which is name, population, terrain, and climate, which these models have. If you notice, I named them exactly as they are named in this JSON response, and that is because in Swift we have a protocol called codable. We can confirm planet to codable, like so. And what this will allow us to do is that under the hood, what Swift will do, it will generate a code for us that will basically assign the value with the same key to this property. So we have our own model parsed. But if you noticed, this is the planet, right? And the response is actually this whole thing. So planet is just part of the response. So I'll add the new struct planet's response model, which is, I'll also grab just the two properties. And it's basically also the same logic, same name as the keys here. So I have results and count. And because planet already confirms decodable, I can confirm this decodable too. Oh, sorry, codable. And types like integer, string, they already confirmed decodable by default for you. Now, the interesting part lies in like different nitpicky things. Like, for example, what if I don't want to name this results? I want to name this planet. What if I don't want to have a rotation underscore period, but rotation period instead? What we can do to handle that is I can create an enum called coding keys with a raw value of string, which is basically similar to the enum that I showed you before. And it will confirm the protocol coding key, which is also a protocol that comes standard. And what it does basically is that this code is usually generated under the hood, but we basically override it for the system. So I'll create a case count and case results. And what it basically does, as you can probably guess, is that the raw value of, for example, results is results. So during parsing, using the raw value of an enum key, it will assign the property value. So what I'll do here, I'll rename this to planets and name this planets as well. So what will happen under the hood is that results will be parsed into planets, but assigned to a variable called planets instead. And that's basically all we need for the model parsing. Now for here, I'll create a new folder. I'll call it networking, and I'll create a request method. It will be the same enum that I showed you before, request method with a raw value of string, right? Yeah, except for before I did not make this post uppercase, but here I will for the reasons I'll get to later. And this is the only thing we need for the request method. Okay, now the next thing that I want to do is basically create the protocol that I also showed you before called network request. Network request. And this is the same protocol that I showed on the presentation, except for I added a few more things into the extension. So for example, the body for the request will be nil by default, query items are nil, and header will be content type application JSON, because that's what you usually want for a mobile app. If you don't provide that, some APIs might return XML, and you don't want to parse XML. That's not exactly the best time to spend. And I'll create now the meat and bone of the network client, a new class called network service. Oops. Okay, so for the class network service is I'm gonna do what we discussed before is generics. I'm gonna create a generic method called make request. Now, for the type, what I want is actually to provide the new generic method, generic definition of a type called request. But I want whatever is provided to us to conform to protocol network request that we've defined before. Oops, network request. So this is the protocol that was defined here. This is it. And network request here, it also has a model, which we're going to use. That's why it's an associated type. So we don't have it as a property, but rather than a type reference. So I'll say the request needs to be a request because I defined it here. If I would have said T here, I would need to say T here. But for readability purposes, I'll just say request. And I'll say that this asynchronous method, and it can throw an error because when you're dealing with the network, it vast majority, 100% of the times, it can throw you an error for vast majority of reasons. And what I want to return for us is the request.model. Okay. And model will be defined by the request model that we'll make internally. Now, for if you have an iPhone and you have an app that makes a network request, chances are what they're using is URL session.shared, which is a basically shared URL session that is provided to each application by the system. And what it has is called a method data4. And data4 method is interesting because it takes type of URL request, which returns us asynchronously data and URL response. This is, by the way, called a tuple, basically two values grouped together, but they're not part of the same data type. So how do we get this URL request? Well, we have a network request. So what I'm going to do is I'll create an extension to the network request protocol, but this one is going to be a private. And here, what we will do is that each entity that will confirm to the network request protocol is now able to get a property called network request. Sorry, URL request, which will be of type URL request, which is, again, the default type provided by the system. And I'm going to use a question mark here, indicating that the result of property URL request is not exactly guaranteed because the creation of URL request may fail. So the first thing that I want to do is create the URL components. I'm going to use a var because it will modify those components. Of course, my spelling is not exactly good now. And I'm going to use this URL, and the URL will be base URL because this is an extension to the network request protocol that I have here. I can access the base URL, and because we are resolving against base URL, I'll say true. And this, what you notice, is that URL components are optional. So because of that, what I'm going to do, I'm going to use a guard condition. And what guard basically does, consider it's like if, but it forces you to have an else condition with something like to throw an error or just return. So for now, I'm going to say return nil. Basically, we failed to create a URL. However, this should not fail for now, for us. Now, URL components is important to us because it has a few properties that we discussed before. It has a path, which we can also grab path from here. This is the property. And it also has URL components dot query items. Now, if you see query items are a type of URL query item, which is also a system type, and our query items are actually a map. And because order does not really matter, so what we can actually do is get our query items, and we'll map those values. Like that. I just press enter a couple of times, and now it did it for me. URL query item. Now, when I try to, I can close this. Oh, actually, I can just make it lower. URL query item, what it can do for us, we can initialize with name and the value. If you go back to the example with this string, remember there was q equals Swift. So the name would be q, but the name for us will be a key value of the dictionary and the value. So what map actually does, it goes over each key value pair, and it gives us the key and the value. And we basically make that a custom object. Now, what we want to do from this is actually another guard because you grab a new complete URL from URL components. So what do we do? Let URL components dot URL. Okay, I'm going to do else, and I'm going to say return nil. We failed to initialize. Okay, and this is basically the root of the URL. Now, before I also mentioned like the body, headers, and the method. And what we're going to do now is we're going to create URL request with URL, which is this URL. Okay. And URL request has some properties that we do need, like HTTP method. For example, if I do option click on HTTP method, it will say that default value method is get, which is uppercased, right? But because we have a method here of type request method, what I can say is just method dot raw value. And the raw value will be interpreted from the raw value I provided before. So in here, it would be just either get or post. For today, we're just going to use get. But if you want to later add like post, put, delete, it's easy to do. There won't be any changes even needed to network service, just to the enum. And then URL request also has header fields. If you notice, header fields is a dictionary of key string, and value also a string. And surprising how convenient that we have the same types, basically. So I can say headers. Now, the body is interesting because the body is, if you look at it, 1 second, HTTP body is type of data. So how do we transform our dictionary of key string and value, basically anything you want, to something called data? Well, what we can do is we'll unwrap, because the property is optional. We'll do something called unwrapping. I'll say if let body. And now if we hit this if, we basically know that body is actually there, so there is some value to it. And what I'll do is I'll use also a default class called JSON serialization. And I'll say JSON object, data with JSON object, and this will be JSON object body. Now, this method actually throws, but because I know that it will actually properly convert that to proper data, because I already have that as a proper dictionary. So what I'll do, I'll say try, but I use a question mark again to indicate that I don't want to handle any errors here right now. And what I'll do here, and just say return URL request. And this is how you get a URL request type. Now, for what I'll do here, I'll do guard again. And I'll say let URL request equal to request, which I get from here, dot URL request else. Now, else is a bit funny because now I need to throw an error, right? So what I'll do, I'll create a new enum here called service error. And let's say, I define a new case here called failed to create request. Now, if I return that, I actually throw it, which indicates that the execution will stop and we will go back. It will basically give us an error. And that actually happens because this needs to confirm to protocol error. And you can basically confirm anything to a protocol. Do you mean throws? Oh, sorry, throws. Thank you. Now, what I'll do is, as you may remember, I'll do the URL session.shared, which is again available from everywhere, and give data for URL request. And I already have this URL request here. But as we established, it returns us a tuple of data and response. This is how you basically do this. Now, this is a throw-in method data, so I have to do try here again and await, which basically indicates that this calling this method is a synchronous method, so it's performed somewhere in the background. So I am awaiting for this method completion before I can execute the next line of code. And once the code reaches this line, I basically know that something has returned here. And what I want to do is actually this data, what it does, it returns to me URL response, but I want to cast it to actually one of its subclasses. So I don't want to have a URL response. I want to have response as HTTP response, which is called process called casting. I basically cast response to one of its subclasses. I'll call it HTTP response. I'll say guard. And the reason I do that is because HTTP response has something called status code, which is, if you see in here, this is our status code. Usually you may check for status code to be like between 200 and 300, because usually something that starts with 2, it's a good response code. But for simplicity's sake today, I'm just gonna make sure that it's 200. And if it's not, then I'm gonna throw an error. And I'm gonna define a new error here called invalid response. and I'll say service error dot invalid response. Now, here comes the most interesting part of the parsing. I'll do a return here, and I need something called JSON decoder, which is again the native type, which every application has access to it. And I'll do decode, and I'll decode this model that is provided to us by the protocol. Because it confirms decodable, we can provide it here, but because I'm referring type, I need to do .self at the end from data, and data will be the network response. Now, this is also a thrown method, so I'll do try. Notice I do not need to handle any errors because this method is thrown, which means that basically this error will be propagated to whoever called it. Now, an interesting, a bit of optimization I can do here is create the decoder, decoder here, so I don't have to initialize it every single time. Okay. Now, this is basically the meat and bones of our network client. We have request method, network request, and we have the network service. What we also now need is the way to make that request. So I created this protocol network request, but nothing actually confirms to it yet. So what I'll do, I'll create a new file. I know there are a lot of files, but this should be the last one, I hope. I'll call it planets response. And I'll say struct planets response, and I'll confirm it to the network request. And the compiler should give me an error in any second. Okay, and if I press fix, notice is that it only wants me to confirm to just a few, to confirm to this protocol, it only wants me to provide just a few properties. So it wants me to provide the type of the model, response model that it will be parsing, which will be planets response that we've defined here earlier. Sorry, where is it? It was in planet. Yeah, planet's response here. And the base URL, what I'll do is I'll create a computer property, which is basically I will not assign a value to it. I'll just open the curly braces here, and I say .swappy. Now, .swappy is the type of URL that I created here, which is https swappy.dev. Like I said, it already has a schema. This is just for convenience sake. I can replace this here, and it will be the same way. It basically wouldn't make any difference. Now, the path that I want to provide is actually API/planets. Okay, and this is basically the request that we have to make. Now I have planets fetching service before, and let's see if I add the planet mock planet here. Oh, yeah, and relaunch the app. It will launch in a second. It will launch in a second. Yep, it has only this mock planet. Now, how do I actually make it fetch information for me from the web? As you see, this method is already defined as asynchronous and that it can throw an error. So what I'll do here in my class, I'll create the reference to the network service, which is the class that I created before, and I'll just initialize it. Now, what I'll do is I'll create now a request. I'll call it this variable actually, planets request. Planets response. Sorry, I meant to name this request. It's planets request. I'm sorry. This was supposed to be planets request. I just initialize it. And what I do now is I'll say network service dot make request, which will be planets request. Let planets response. I'll say try because this method is thrown, as we remember from the network line that we created, and I'll say await. So this basically means, again, that next line that is executing code, this means the data is already returned at this point. Now, what if I do this, if I just say return planets response, the compiler will actually give me an error because I said that for the planet request, here, for the planets request, the response model is actually planets response, but I want the array to be planets, so I just say dot planets. And if I actually, you know what, I'm just gonna, for simplicity's sake, I'm gonna go to network service and I'm gonna add print request for URL request. Okay, and I'll just relaunch that. Give it a second. Here we did a request for /API/planets, and this is what we have. Now, we also can provide like maybe different parameters to the request. For example, I have like a similar request based on this, which is planet information request, but it has a planet index. So if I go back to the API and I do / for example, 1, it will give me only one planet here. And to achieve this in this planet information request, what I basically have is the same identical request, except for I have planet index here, and I also provide planet index at the path. So what I can do in this planet fetching service is actually, I'll remove this fatal error, because if I click something, the application will crash. So what I'll do, I'll say planet request equals to planet information request at index. And the index is already provided to me from the UI. And what I'll do, I can basically copy paste this line and paste it here, except for replace the planet request for the planet request, right? I'll call it planet response. And I can actually, for simplicity, I can just return the planet. If I relaunch that and I click on any planet, it will provide me any information for it. Now, and this basically is all you need to do. The only thing, if you were to scale that, what I would have to do is to add maybe different models that conform to network request protocol with a specific properties. But this is a very simple way to create a network request client. How am I doing on time? Sorry, I kind of rushed through it. Any questions, comments, concern, thoughts, feedback? Thank you. Thank you. Yeah. I worried I wasn't going to make it in time because I had to go through so many things, but actually went kind of fast. Oh, right. Something I forgot to mention. We did not use the body for the request because this API does not technically need that. But if you were to need a body, let's say, for example, I have the network request here. I have already provided the body to be nil, right? But if I want a body here for the planet information, I can say that the body is, I don't know, ID equal to index. However, it will give me, oh sorry, planet index. However, it will, when I will make that request, it will give me an error. This system will give me an error because we provide a body. And if you were need to provide the query parameters, I'll go to planets request here, and I'll provide query items just for the demo purposes. And if we go here, I'll go back. This is what the query parameters it has. And let's say I want to do the same. I want to provide page equal 1. Oh, sorry. And this is the query parameter that is generated for us. For the network service, the query parameters, usually you need to combine them using ampersand signs, but thankfully query items does that for us. The system will basically do that for us. And I can have like different properties, like basically I have planet index on the planet information request. Just provide that in to the query parameters instead. Okay. Now it should be mostly it. In your experience, is mobile development easier or harder than web development? Each has its pros and cons. So mobile development, you mostly dealing with like business logics, network requests, right? Maybe some performance issues, but it depends, I guess, what you mostly like. I like mobile development because I usually see the feedback of what I'm doing on my mobile phone. But it's not to say that web development is not important. Any other questions? What is the best way to learn mobile app development? I would say it's best way to learn with anything. You just pick a small app, small projects that you want to create. Don't try to create like Instagram or Facebook competitors from day one. Just something small. Maybe try to recreate this app that I have here, just that displays your list of planets, right? Try to recreate that, and then you just add more functionality to the application, to your application, right? The best ways to learn is basically not get stuck in the tutorial loop, but basically try to create your projects and learn from that. Yeah, just play around with it. Don't be like learning for the sake of learning new stuff. Yeah. Hope that answers it. Any other questions? No? Okay. Thanks for having me. It was my pleasure.